In this section we're looking at how to find the volume of a rectangular prism. A good example of a rectangular prism is a room. The walls are vertical and opposite walls are parallel planes. The floor and ceiling are also horizontal parallel planes. So each of the faces that intersect do so at right angles. Now let's look at the features of a right rectangular prism. The word right reminds us that you find right angles in the corners of the shape. First of all, the base is a rectangle, and I've shaded the base in blue, but note that the base can actually be any face of the shape. Secondly, if we slice through any horizontal plane, the cross section is a rectangle and it's congruent to the base. So the shape is regular throughout and each slice has the same area as the base that is parallel to it. And there are also 3 right angles at each corner. Now let's just revise the idea of volume itself. The volume of an object is the amount of 3-dimensional space that it occupies. In other words, how much space a shape takes up. We measure volume in cubic units. Here's some typical examples. Millimeters cubed or cubic millimeters. It's the same as a single cube that is 1 millimeter by 1 millimeter by 1 millimeter. And it's about the size of a mustard seed. 1 cubic centimeter is 1 centimeter times 1 centimeter times 1 centimeter. And it appears to be about the size of a blowfly. And then cubic meters, 1 meter times 1 meter times 1 meter. Obviously a much larger unit, but these are the 3 most common units we use in the metric system. We also need to understand the connection between volume and capacity. They're very similar, but capacity normally is used to apply to fluids rather than solids. In the metric system, litres is probably the main unit we use, and 1 litre is equivalent to 1,000 cubic centimetres. Alright, so now we're going to focus on figuring out how to work out the volume of a rectangular prism. But first we should note that they're also known as cuboids, and there are a couple of special examples. First of all, if there are 2 square faces, it's going to be called a square prism, and if all of the faces are square, we simply call it a cube. So in the diagram here, I've shaded the top layer, which is made up of 6 cubic units. And you'll observe that there are 4 layers. So the volume of the entire prism is simply the volume of 1 slice multiplied by the number of slices. In other words, 6 cubes multiplied by 4 to give us a volume of 24 cubic units. Now to work out how many cubic units there are in the base, this is actually equivalent to finding the area of the base. In this example it's just 3 times 2, or length times width. 3 times 2 equals 6, and then we take the area of the base and multiply it by the number of layers, or the height of the cuboid, and we then get the volume. So there are 2 formulas that we can use. The first is simply the volume of a rectangular prism is length times breadth times height. Instead of using the word breadth, we can also use the word width. So length times width times height. We've got a very simple example, and let's just remind ourselves that in geometry, often difficult problems can be made simple by drawing a good diagram that's labelled. Then we would write down the formula, substitute the values, calculate, and then finally check that we have everything right and the units are also listed correctly. Okay, so a very simple example, probably so simple we don't need a diagram for this one, but we should start by writing down the formula, volume equals length times width times height, and now we substitute the values. Note that it really doesn't matter which of those three numbers we consider to be the length or width or height, because we can multiply in any order, and the answer is 192. The units are cubic centimetres in this example. To get a second formula, we return to the idea of slices. So this is the example from your textbook. I've shaded the top layer, which we can think of as the base. So if we find the area of the base, which is 4 times 3, and multiply it by the number of layers, which is the same as the height, we're going to determine the volume. So there are 5 copies of the top slice, and to find volume is simply area times the height. And remember that the base can in fact be any face of the prism. So here it is, another very useful formula for determining the volume of a rectangular prism. So to finish the example, the area of the base is 12 multiplied by 5, and we get 60 units cubed. So here's the summary. 2 formulas. Volume is length times width times height, or volume is the area of the base times the height. You can now go ahead and try these exercises. You should find them fairly straightforward, and in the next section we'll look at finding the volume of prisms that are not regular but are made up of composite polyhedra. Something to look forward to.